Diagon Alley operates as a dense, magical microeconomy. It is a perfect real-world laboratory for seeing how the basic laws of economics actually function. As you walk past these storefronts, consider a practical question. How does a shopkeeper decide what to pay their employees? The answer lies in the storefront. An apothecary owner hires potion makers because customers are demanding the potions they brew. This is derived demand. Employers only need labor because shoppers need the final product. We can track these invisible forces, what shoppers want to buy and what workers can provide, using a visual market dashboard. We measure wage rate on the vertical axis and quantity of labor on the horizontal. We map a downward-sloping blue line for employer demand and an upward-sloping red line for worker supply. They cross at equilibrium, determining the baseline wage, W1, and workers employed, Q1. For your exams, remember this. The firms are the ones demanding labor, and the workers are the ones supplying it. Confusing the two is the most common mistake students make. Wages represent the specific point where the employer's need for help and the worker's availability reach a state of balance. Now we can simulate a systemic shock. Suppose a sudden trend causes the demand for magical potions to skyrocket across the entire economy. Potion-making businesses must rapidly expand to meet those orders. Because each potion sold brings in more revenue, the staff members who brew them become more valuable to the business owner. On our dashboard, this surge in employer demand shifts the demand curve outward to the right, moving from D1 to D2. The new intersection shows a clear result. The wage rate climbs to W2, and the number of workers hired expands to L2. When consumer demand for a product surges, it puts upward pressure on both the wages and the total number of people hired in that industry. Let's simulate a different shock. Imagine a sudden influx of dragon tamers immigrates into the economy, all looking for work at the same time. This event changes the availability of labor, regardless of what the employers were originally asking for. We map this by shifting the supply curve right from S1 to S2. With more workers willing to work, the dashboard shows a new intersection. This oversupply means the wage rate drops to W2, even though total employment increases to L2. When the supply of workers outpaces employer demand, businesses can fill their open roles for less money, which pulls overall wages down. The theoretical simulation ends here, but the practical application begins with a formal 6-mark exam question. The prompt asks you to analyze, using a demand and supply diagram, how an increase in demand for restaurant meals may affect the wage rate that chefs are paid. First, state that the demand for chefs is a derived demand. It is born entirely from the consumer's demand for restaurant meals. Second, draw your baseline equilibrium. Ensure your axes are labeled specifically for this scenario: wage rate for chefs and quantity of chefs. Third, show the shift. Draw the demand curve moving to the right and label the new line D2. Fourth, mark the new intersection point. Draw your dotted lines to visually confirm that both the wage rate and the quantity of chefs have increased. Finally, explain the logic. Higher demand for meals makes a chef's labor more valuable to the restaurant. Since their work now brings in more revenue for the firm, the owners pay higher wages to attract the staff they need. Mastering these diagrams allows you to visualize how the real world values human labor, showing exactly where the interests of firms and workers meet.